but not multi-frames.
But so a TD won't feel a difference when he hot punches between IP sources without having to preset them. Not doing a ME bus switch, but actually switching hot punches on a router panel between IP sources. Will he notice that latency?
No,
Okay.
you will not notice.
That's amazing. That's great. Okay. I'm sure we have lots of questions from the audience. Do we have Tim up? Tim, I see you. Can you hear us?
I can hear you now. I
Excellent.
I didn't hear Hugo, but I can hear you.
Okay. You got that? All right, Fred, we'll start with you.
Yeah, my question is for Tim, and it
Yes.
relates to something that you described as a way of extending the use of IP packet destination and source and destination address. But at the same time, you also talked about using commercial off-the-shelf IP switches, just as Hugo talked about here. My question it has to do with something like that. Does that fit in the category of a SMPTE standard or an engineering guideline or a recommended practice, or should something like that be submitted to the ETF as a request RFC type of a standard? How do you picture that? What seems like a conflict to me in a final product. Is it standard or not standard is basically the question.
Is what standard or non-standard? I'm sorry, I had difficulty understanding
the way
question.
the way that you talked about changing the processing routine for IP destination and source addresses.
Oh, I see, yeah.
It was like an extension or something, I think you described.
Well, I don't think that it's really necessary. I think that's more of an implementation detail inside the destination device. So I'm not sure that there's a standard necessary, but I'll defer to my colleagues on the panel if they have another perspective.
Okay, but the basic question is, if you do that as a Snell implementation, then is it standard or non? Will it still work through a standard commercial off-the-shelf Ethernet switch, layer 2, layer 3 routing?
Oh yeah, yes, absolutely. Absolutely, it will. I mean, that's we're not doing anything with any switch technology that is specialized in any way, and we've used a variety of switches from different vendors in our development. I think that I may be misunderstanding the question, though. If you're talking about destination switching, it's really just a question of the device, getting both streams and making sure it understands where the frame edge is and doing the switch. And it's doesn't really depend a lot on the upstream IP networking technology. If that helps to explain it.
Yeah, I think maybe I understand what you're saying, and maybe it's just a way of looking at the source and destination address in an IP packet and then drawing some conclusions about what to do with that intelligence or information, I guess I could call it.
Yeah, perhaps.
Okay. All right, thanks. This is probably worth a longer discussion at some point.
That'll be fine with me, and I'm sorry if I didn't understand very well your question.
Any other questions?
All the way in the back.
Jonathan.
Great presentation, guys. Thank you. Regarding the switching of video, Hugo, you showed a graphic where you had 2 streams in a single pipe. I know it was just a graphic, but working off of that, and you talked about frame counts, packets being tagged with frame numbers. Are those frame numbers unique to time of day with frames so that they line up, or can it vary? And what I'm asking specifically is with redundant connections, if you had diverse paths and there was increased latency from one to another, it could cause the signals to align. So if you're doing a football game, for example, and you have a high camera and a low camera, and those signals arrive at different times when you switch, if those frames aren't tagged with unique incrementing hour, minute, second frames, you won't be able to line them. Can you just talk about that a little bit, how that's handled?
They can be made locally aligned or GPS aligned or precisely. there are a number of ways to do that. The PTP protocol allows you to synchronize. And some people are saying, I'm going to tie myself to the epoch, which is a little bit complex. But by having a GPS information or your local generator, you can create a specific to your plant PTP time information to genlock your truck along with the other facilities.
Okay, a question from Norm Stein.
Good morning, everyone. For the panel, general comment. Many of us in the room here have grown up on SMPTE color bars as standards for test and measurement as technology moved from film to analog to digital. So what would you envision color bars looking like, and what type of data representation would you envision SMPTE color bars representing in the IP/IT world?
I guess I view them as kind of separable problems, that a lot of what we're talking about here is how the video moves around. The definition of the meaning of the video, the high dynamic range, or all those things, is kind of a tangential problem to how it's carried. There's a huge amount of work going on in that in SMPTE, and if you want to get involved, please do. The whole transition to UHD has brought a lot of discussion about high dynamic range, extended gamut, and so forth, and it's a soup of activity that's looking for more people to participate in it who understand the problem. So if you're interested in that topic, please get involved in 10E where the bulk of that activity is going on. Yeah, but it's unrelated to the IP transport. We just get it there.
Yeah, thank you. I have just a second question for Hugo. I've recently attended several weeks ago a conference in the Atlanta area, AUVSI. It's an unmanned symposium on robotics and drones and the like. So since Sony is here representing at least one camera manufacturer, and I know there are a host of others, could you make a comment, Hugo, on the emerging area of unmanned aerial photography, news gathering, and the like that your company and others might be looking at?
Or is that a different something?
Are a completely different subjects. I mean, we are the largest manufacturer of CMOS sensors, of imaging sensors in the world. I mean, we can make any CMOS to go anywhere, but the control environment, that's beyond our objectives.
Good morning, gentlemen. There was a time when we could replace a Conrack monitor with a Sony monitor, or a Kagami camera with a Sony camera, and just pull the BNCs off the back of it, and those BNCs would go back on, and we're back in business. Are you evolving to a similar protocol with IP connectors, so we can take one manufacturer out, put another one in, and the IP standard will work for all of them?
Rock, paper. You know, as I mentioned, I was talking about the audio situation, right? In the audio world, there was a lot of vendor diversity, and there were 10 different vendor solutions, and then the standards sort of caught up. And so by, I don't know, pick your favorite, by maybe 5 or 10 years from now, I think the audio world will have finally converged onto AES 67 as the thing they all do, and then they have legacy modes to support all the hegemony of things that they built in the past. We're trying as a community of vendors to avoid being quite as diverse as the audio world. But that said, you know, there's a lot of interoperability around 2022-6 with vendors who do it. There's you know, Sony has got the RDD out there for IP Live, and there's other things being proposed as well. Tim even mentioned VC2 as a possibility. So there is a little bit of shaking out to happen, and at the same time, we have each of us early adopter customers who are building something. So I think that there will be a phase of experimentation in the industry where we figure out what sticks, and the standards will progress in parallel, but we're trying to avoid the, you know, sort of widespread I don't want to say chaos, but the widespread challenge that the audio industry created. I think the standards and the reality are closer together on the video side than they were on the audio side. The audio side, the standardization came much later than the widespread adoption.
I always have this example in my head. Back in the 90s, 91, 92, when we were creating the serial digital interface, there were a number of proposals that were very nice on paper, but they were really very inefficient to manufacture. And at the time, we were a very small number of manufacturers involved in broadcasting. And we decided go for broke, and we created SDI. And then SDI became a de facto situation that eventually became a ratified standard. But there was the need to create a logical implementation that will satisfy the requirements of the marketplace. If we had opened the discussion back then until trying to find the ultimate answer, we will still be using NTSC today, because people will not gravitate to a single solution. The same thing happened with HDSDI. I was the chairman of the committee. Some people say, oh, I want fiber channel, I want this. Guys, it's gonna go this way. And now we have HDSDI. Then I'm not saying that this is the situation, but there are more than 160 participants in the committees, and everyone wants a different elephant, a pink elephant, a green elephant. That's not the way we're gonna create a business. It's a big problem.
As another boots on the ground kind of comment to get your reaction, I love seeing all this talk about redundancy, and you're building it into the hardware now. But one problem that we see a lot in the field is that you have a redundant system, but then it doesn't bother to tell you that the primary failed. So you're running on the secondary for months with no indication. And if I hear SNMP as the answer, I'll go, okay, great, but it's not as easy to implement, and it is not user-friendly, to put it mildly, let alone what you have to do to implement it. So your comments?
Absolutely agree with that. The system is very intelligent. The software layers will tell you that given port has failed, and you will never notice that the port failed because the signal has no disruption. We need that intelligence to tell the end user at the end of the day, replace that switch, because your point is very, very, very much in.
Right, but
we really like red light, yellow light, green light.
Well, it's I'll add to that though by and large the equipment in your plants, and I'm saying this very generically, but the equipment in television plants actually today even generates an enormous amount of telemetry about what it's happy about and what it's not happy about, and EDH errors from SDI and all kinds of things. In the vast bulk of plants, all that telemetry goes nowhere. And it's a choice, because we've gotten by as an industry by putting a bunch of pips up on a screen and just watching the end result and saying, oh, end result's good, everything must be good. And we've not, by and large, in most facilities, invested in doing anything with the information that is coming streaming out of all that equipment all the time. So, the information's there, and in some particular large facilities, they've invested in creating monitoring environments that actually analyze that data. But in particularly smaller facilities, it's so easy to just put up some pips and watch the end result, and if it's good, it must be good. So it is a choice. It's an investment choice as you design facilities to consider monitoring by telemetry as opposed to only monitoring by pips.
I think it raises an interesting point, because when I come out of doing field production early days, and it's a very linear signal flow, and you know exactly what signal is supposed to be on what cable. When something doesn't work, you quickly triage 50% up the cable line, check something in the device, doesn't work, is working, okay, now you know it's down here, and you can find something. Now you have a system where I have multiple signals on the cable. I don't even necessarily know what signals are on what cable between two routers or something. And I can't just unplug a cable to plug it into a test device, because who knows what's on and what else I'm disrupting to test whether that signal's good there. So we're going to become very dependent on systems-aware monitoring systems, especially in a live production environment that are agile and and monitoring system and aware of what's being connected and actually, self-learning about the system, and then knowing, I mean, it's going to be a whole new complexity of monitoring systems, isn't it, to make this work?
Yes, a meaningful presentation of the telemetry of the system will be even more important.
John, will you come back next year and Hugo talk about monitoring systems?
It sounds like
How we're
it.
going to make all this work? More questions?
Yeah.
All right, how many of you are ready to go STI this year? I mean IP this year. Forget we were STI.
Oh, the inverse question.
Okay, good. All right, are we done? Great. Thank you all. That was a fantastic set of presentations. Really.